Okay, let's get started. Well, thank you everyone for joining today, and welcome to our webinar, Managing HCS with Terraform Cloud. My name is Peter McCarron. I'm the Senior Product Marketing Manager for Consul, and joining me today is Cody Arkland. He's our Technical Product Marketing Manager for Consul. So through this presentation, feel free to enter your questions into the chat. We'll be answering them at the end. The session is being recorded. We're going to post it on our website within a couple of days. Usually takes us about 1 to 2 days to process everything, and usually we'll pair it with the slides as well. So to kick things off, I want to go through the agenda of what we're going to be covering today. So first and foremost, we're talking about HashiCorp Consul Service on Azure. Some of you may be familiar with Consul, but we're going to talk specifically about the platform that we're offering with Azure today. We're going to talk about Terraform Cloud. Why are we doing this with Terraform Cloud? What is it exactly we're going to be doing? Then I'm going to turn it over to Cody. Cody's going to walk you through a whole bunch of setup steps. He's going to show you exactly how you can get started with this if you decide to do it on your own, as well as show us some of the examples of what some of the configurations that you can do with Terraform Cloud are. After that, we'll give you some next steps as far as like how you can get started on your own, and then we'll open it up for Q&A. So let's dive into what HCS is. So if you've been following us over the last year or so, you've probably heard us talking about HashiCorp Consul Service on Azure quite a bit. We introduced it at HashiConf last year, and then most recently, it went into general availability. And the real key driver for what HCS is going to help you do as a user is it's all about 2 different use cases. So service discovery and service mesh. Service discovery is fairly self-explanatory. The idea is that as I start moving more and more applications into an Azure environment or across multiple different platforms or different environments, I need to have this kind of real-time information about where all of my services are running. So how can I quickly find out where my applications are? Do I know if they're healthy? Are they reachable? What's the real easy way for me to be able to do that? And so Consul is going to be able to provide that functionality for you from day one. As folks are starting to get more and more advanced, though, what we're finding is that they need to find a way not only to discover applications, but how do I enable an automated connection between those applications and do it in a secure fashion? So service mesh is really kind of a buzzword right now. A lot of folks are very familiar with it. Usually in the reference of like Kubernetes. So if you're starting to get into like an Azure Kubernetes deployment, you may be looking for a service mesh option, and Consul is a great fit for it, as well as HashiCorp Consul Service on Azure, because it's all going to be supported on the same platform. And some of the features we'll be getting into the demo, but the idea is that you really want to have something that's going to provide security, encryption, as well as enable you to be able to kind of bridge that gap between your networking capabilities and the application deployment lifecycle. This is a really critical thing that if I'm starting to take on a more modern application deployment approach, is there a way for me to bring the networking component along with that so that I'm not running into the situation where I'm slowed down or I create a bottleneck for my network operators? So the question is why do I need HCS? And so I kind of touched on it a little bit, but the idea is that I have all these different applications that are running. Maybe I have some front ends, maybe I have some APIs, maybe I have some databases all running in Azure, and I want to know where these things are, and I want to be able to securely connect all those. So Consul becomes that glue. And the beautiful thing about HashiCorp Consul Service on Azure is that if you've selected Microsoft as your primary cloud and you're using a lot of Azure native services, this becomes just another one that you can leverage rather than trying to incorporate some other type of third-party service. So the other piece that we really like about HCS is that not only is it natively supported within Azure, but it is a managed service. So the layout or the process of being able to connect a lot of different applications can be a little bit complex. There's a lot of challenges that folks have as far as getting these clusters up and running and doing it in such a way that they aren't creating this extra operational burden on their networking folks. So they're really trying to figure out like, what's the way that I can take advantage of those capabilities, but be able to do so in a very quick and turnkey fashion. From just a pure like functionality standpoint, and excuse me, go back here over there. So the real benefit of HCS is that I'm going to offer simpler app deployments. So I'm going to be bridging that gap. I'm going to enable quick on-demand discovery. But the other piece I touched on is definitely that Azure experience. So if I'm using a lot of Azure services and I want to manage everything through my Azure dashboard, this is all going to be part of that same workflow. We're always trying to reduce the barrier for folks with their workflows. We're trying to solve a technology problem. We don't want to interrupt and force you to kind of incorporate a whole new service. And we're going to talk about a different workflow with Terraform Cloud, but there are a lot of folks who are saying, I'm doing everything in Azure today. How do I have a consistent way to use another tool to accomplish the needs? And the other part of it is the customer support aspect. At HashiCorp, we pride ourselves on being able to help folks with their needs. We offer uptime SLAs on our production and our annual basis with HashiCorp, with HCS. And you're really going to have that single point of contact to help you in the process. So I've talked a little bit about like the HCS component of things, but you might be saying that this sounds a lot like Consul. Like when I talk to folks at HashiCorp, or I talk to other users for Consul Enterprise, they mention a lot outside of that native Azure experience. They talk about the functionality being very similar to what I just mentioned, as well as the support aspect. And the reason is because at a high level, it really is all the same, right? Like if you think about it, it's really about how you want to deploy Consul. So we think that the technology is going to be very useful, but it really depends on the need for your business of which option you choose. So maybe if you're just getting started, or you have a small team of people who are doing a greenfield project, maybe you start with the open source version. If you're starting to get a little bit more savvy and you're looking for something that's a little bit more production ready, or something that you can have some sort of SLA around, that's where you start looking at our managed offerings. So you do something like HCS, or we also are going to be offering HCP on AWS, which we mentioned at our last HashiConf. It's currently in private beta, but you're looking for a little bit more of a UI focus. But then also, if you do have some regulatory compliance, or you have some different needs, you may say, I'm not quite sure that I'm going to use a SaaS solution. We do offer a self-hosted. And this isn't supposed to be like a progressive journey. It's really more about like what's picking the right solution for your business's needs. But the capabilities are going to ultimately be the same from service to service. So stepping away from the Consul and the HCS side, this is about Terraform Cloud also. As I mentioned quite heavily early on in the presentation, I talked a lot about like the native Azure experience, this idea that if I'm doing everything in the Azure dashboard, that I can just incorporate HCS as a part of that flow. The challenge here is like we're not doing it as part of that flow. And so the question might be why? Why are we looking to do something with Terraform Cloud as opposed to doing it through the Azure dashboard? And really layering in Terraform Cloud is going to offer some really nice capabilities that Cody's really going to dive into. And I think what's really interesting about it is that it creates a new workflow for your organization, but it might be something that they're already familiar with. So from a collaboration standpoint, Terraform Cloud is going to offer the capability for multiple operators to be working together. So one of the things we're going to be showing you is around this idea of versioning, or being able to do things in GitHub and then commit them and make sure that they are applied to my environment. The connection between TFC and HCS is going to allow me to be able to have a seamless way of doing that. It's also going to create that consistent workflow for management. So if I'm an application engineer, or if I'm a developer who's going to be applying these changes, I'm not necessarily going through a ticket queue. I committed all the same way that I was doing previously with Terraform, but now I can incorporate that networking component, which is really, really helpful in bridging that gap that we mentioned earlier. The other part is that it's just going to be easier for the organization to do things as a whole. If you're already leveraging Terraform Cloud, it becomes easy to be able to not only deploy it within that individual group, but as you incorporate more and more teams within your organization, Terraform is really easy to share, right? Like taking those Terraform manifests and being able to share them across an organization is going to be a really powerful way to spin up additional environments very, very quickly. So that's kind of the high-level marketing aspect things. Now I'm going to turn it over to Cody, who's going to get into the actual, like, what does this look like, and walk you through how you can start using Terraform Cloud with HCS. So Cody, I'll turn it over to you.
All right, I'm going to assume that my screen is working on this new platform that we're using. And I'm going to spin up my my desktop sharing now, so we can take a little bit of an explore around. All right. You should be seeing my screen. If not, Peter, yell at me, but I'm going to assume that my screen is showing successfully and just start cruising forward. So here we have the Azure portal. We're taking a look around what my actual Azure account looks like. If you wanted to provision out HCS, HCS lives directly in the Azure managed catalog. So we can actually come in here and we can do console on the search bar. which will ultimately return back our HashiCorp Consul Service on Azure. So I can pop in here, I could select create on this cluster, fill in my details, and I would effectively get this cluster back. It creates in its own managed resource group, which then you end up peering into your resource group. There's a couple big things I want to call out here for people who are just getting started consuming this service. First off, we have these two different types of deployments that we can do. We can do a production deployment, which gives you a 3-node cluster, something that you can actually do real production heavy workloads on. You get all the scaling, all the good stuff around a larger console environment. Or you can do the development cluster. And the development cluster gets you a single node, much cheaper, but the ability you don't have redundancy, obviously, so it's not good for production workloads. But it's a good way to get started with the service, take it for a spin, explore out how console actually works. So highly encourage checking out, at minimum, check out the development service. It's really cheap. The cost is pretty drastically reduced, just so you can get your hands on it and take a look. Just to sample this out, I'm going to fill in some details here. We'll do the deployment development. We're not actually going to deploy this, but I wanted to show the concept. We can also configure out some of the aspects of console, and we'll use these configurations when we go to set up Terraform Cloud in a little bit. You can see Terraform Cloud hanging out up here in my taskbar. We can choose our cluster name. This is more just a friendly name set up inside of your environment. This is really important when you're working with the HCS CLI, and the HCS CLI is by far the fastest way to get console talking with like a Kubernetes cluster in Azure. So if you deploy out like an AKS cluster or something like that, it's a pretty powerful way to get started there. We can choose our data center name, what console version we want to be running. We can choose to enable or disable our external endpoint. This is an important one to call out. You don't want people hitting the UI. You don't want people being able to hit your API for console externally. For development environments, you can enable it. Security best practices to keep it disabled. In this session, we're going to be going through using console with Terraform Cloud. Terraform Cloud has its remote runners capability, so you could spin up your AKS cluster and then deploy that runner onto that Kubernetes cluster and have it able to communicate with HCS and manage HCS remotely, which is a pretty powerful thing. The other thing I'll call out here is this VNet starting IP address. This is the actual IP address subnet for your console service. Now, it's really important to pay attention to this, because if you spin up a set of resources that lives inside that same range, you won't be able to peer those VNets. So you want to make sure that you have that the IP address range very different. So instead of doing like a 16 here, do like a 14 or something like that, just to really set a difference, or even go with a /16 and get away from this range entirely and make sure you're deploying out to like 28 or something like that, just to keep the range different so you can have no problems peering later on. Fortunately, through the magic of space and time, I already have a cluster in hand. So if we pop in and we take a look here, this is what HCS ends up looking like when you get it in hand after your deployment. We can come in, we can see the console UI. I got some stuff deployed in here already, a couple of front-end services, an ingress gateway, a terminating gateway. While these things are here, they're pretty unconfigured at this point, so I have no actual no intentions in place. So if I hit any of these services, they're not going to work for me anyways right now. And that's intentional. Funny enough, intentional. See what I did there? It's intentional because console is deployed in a secure fashion by default, meaning ACLs are enabled, and with ACLs enabled, communication is denied by default. So that's how we achieve that zero trust networking concept, by having these configurations in place so that when ACLs are enabled or deployed in a secure way, you can't communicate unless we explicitly allow it. This protects you from people registering services and having widespread communication inside of an environment. But ACLs also allow us to share access to the environment. So for example, I did a stream earlier with a colleague, Zach, so I created a namespace for him. I know I'm here with Peter as well, so I could go in here, I could create Peter's namespace, do a save, cut Peter an ACL token, and then when he logged into HCS, he would be carved up in his specific area where he could work inside of the environment. This is the internal UI. If you wanted to be able to see the external, you can come into this parameters and outputs, and we can see down here on the bottom is the external address. So if I'll grab this, open up another browser, We can see kind of the full scope of the UI here. A couple things to observe. I've got some upstream set up. So if I go into front end and I look at this pod, look at proxy info, I can see I've got upstream set up. So my service mesh is set up to communicate. It's just in all likelihood failing to communicate right now. If I take a look at this ingress gateway, we can see this ingress gateway is pretty useless. It has no upstreams configured, so it's just hanging out there waiting for something to happen. So that's the lay of our land from a console standpoint. We've got services in there. Things are running. If I switch over into the CLI and I do a kube control get pods, we can see I've got an API, a front end V2, a database instance. I'm running Vault in here as well to give me some secure credentials. So things are looking pretty good. But it's not really doing anything. If I do a get service, I can hit this front end service, which I'll just grab and show. This front end service will come up, but when we look at it, it's not going to actually be resolving to anything on the background. So it's just going to hang there and be generally in a sad place. There we go. Took a few to come up. So these are going to continue to spin, bad things happening, children are crying in the streets. It's a rough time. So what we're going to do is we're going to set up Terraform Cloud to allow us to manage this environment and to allow us to actually configure some of the connectivity details that are needed. But before we do that, let's talk a little bit about what getting a Kubernetes cluster into HCS looks like, because that's a pretty important thing. Typically inside of HCS, you'd end up downloading this set of configuration files, this get config command. So we have this HCS CLI that gives us the path to actually do some interactions with our environment. And if you were working with like virtual machines, you would run this command. We'll run here anyways. And it would give you back a configuration JSON and a certificate. You could take those, drop those onto a virtual machine, and call it a day. If you moved up and kind of leveled up, you could use Packer to build out an image, maybe using the post provisioners to actually customize that image and kind of have an automated console image there that you can use against HCS pretty easily with really low level of effort. But this is HCS. So we provided these ancillary commands. You can kind of see them up here on the top. Generate secret, generate Helm values. These end up providing you out kind of configuration details. So just as an example, if I do an AZ HCS, generate Kubernetes secret, I'll drop this config off the end with my specific parameters for my environment. We'll see that it's going to actually dump out the secret for that federation process. So the federation process is when you take a console cluster and you join it to another cluster. In this case, we're actually just joining that Kubernetes cluster as a client to the node, so it's less about federation and it's more about just configuring it to join up to a kind of a parent cluster. But these configurations here give the user the things they need to bring that Kubernetes cluster in. So you can imagine that all I have to do is take this and I can pipe it out and apply it to my cluster automatically, and boom, my secret's applied with kind of one command line after getting my resources in hand. Same thing applies for the generate bootstrap. Now I've already done the generate bootstrap command. What that does is gives you that initial ACL token for configuring and accessing the environments. That bootstrap token is very important. Those two things together give us the ability to have systems join console. And to do that, what we end up doing is doing a generate Helm values. I'll show that out. Generate Helm values prints out the set of Helm chart details for joining console's environment. So putting this in like kind of plain context, you get your HCS environment in hand, you have your Kubernetes cluster, you run these three commands, the generate bootstrap, generate secret, generate Helm values, you apply those to the environment, and you're going to join up as long as you have your peerings set up and configured in the environment. So it's pretty cool capability. For us, this has all been done already. You've already, in my example, we're already in the cluster. We can see here I have console nodes set up, and I've got that ingress gateway and terminating gateway we talked about before in place. So all that's left now is to actually configure these so we can actually consume them. And as Peter mentioned, we're going to do this with Terraform. So if we jump into this Terraform directory here, actually need to back these into the other directory, so I need to fix that real quick. So we'll do move Terraform. Oh, perfect. If I look at that main.terraform file, it's pretty barren right now. It's a provider. It calls the console provider. It sets an address variable, a data center variable, and a token variable. And if I hit this variables.tf file, we can see some of the configuration details within. So necessary token, data center, and cluster. We can actually feed those values into Terraform Cloud so that the user never has to interact with them. And we'll talk a little bit about why you would do that as we set up Terraform Cloud. So we're going to go do that now. I've already committed this into Git. You can see this with my handy notifier right there. So we are committed into a repo already. Things are good on that front. Things are not good on this front. This front continues to be sad. So I'm in Terraform Cloud here. I'm in my workspaces. Humble Lab is my lonely little environment at home. I'm going to create a new workspace. And I'm going to integrate this workspace with the version control workflow, which means that when I commit code into Git, and I merge that code in, or I actually check that code in, it will run whatever I've turned in there. Peter and I had a conversation about this beforehand, like, well, why would you do all of this inside of Terraform when you can just hop into the UI and do this, or use the API? Because Terraform gives you this really first-class collaboration experience. We can have these be parts of the actual code for your application. So when somebody checks in code, they can have a splitter definition in there that says, when this deploys, I want to stand up a new splitter automatically and have it send traffic to that new service right out of the gate. Terraform Cloud, mixing that with kind of the GitOps approach, gives us the ability to track all of this inside of Git. We can use Git issues, we can PR these changes in, we can have a version history of these changes and kind of the running time state of your application. So if you're already using Terraform for your infrastructure side of the world, why not use Terraform for your network lifecycle side of the world also? So we'll use the version control workflow. We'll hit GitHub. We'll do HCS Consul. And we're going to create a workspace. We can change the name if we wanted to. We're just going to leave it as HCS Consul for now. So this is configuring for the first time. We're going to wait a few moments, and it's going to prompt us to create some variables. I just saw a question pop up on the side of the screen, so I'm just going to answer that on the fly real quick, Peter. Question was, is HCS available directly in the Azure portal or home, or do I need an add-on? No, it is available inside the catalog. So you can actually go into the Azure Marketplace, type in console, and it'll pop up right in there.
Yep, I provided a link directly to the portal as well in there. So we'll make sure to send that out to the chat.
Look at you. You're a helpful gem. All right, so we're going to do a few variables here. We're going to do our console DC. And I'm going to grab that from sitting off to the side here in my handy notes section. So that is Azure HCS. I'm going to do a token, and I'm going to set this one to be sensitive because I don't want you people to steal my clusters. So I'm going to add that there, save variable. So it's sensitive write only, meaning I'll never be able to see that again. And then finally, I'm going to grab the cluster. And the cluster is going to be the actual address for communicating with this instance. This is that the public address for my system. And I'm going to go ahead and check that as sensitive too, just because I don't really want that hanging out in the environment. So we've got this set up now. We've got our variables in place. And we can go ahead and do a first run of our plan. Now, our plan doesn't have anything in it right now. It's just a lonely, sad shell of a plan. It's got the provider that's going to run. So we can watch it start to queue up. We're going to really hope for no demo fails. Okay, so it initialized fine. There's also nothing in there. So it's not shocking that it ran fine. apply doesn't run, but right now our Terraform Cloud environment's set up and it's monitoring that Git repo. So now when we start to make changes, we'll be able to actually commit that code and watch it actually execute. So what we're going to do is we're going to switch back into our terminal session, or am I? There we go. And we're going to hit our main.tf file. Now there's a couple things that I want to do right out of the gate. First things first, I know that my ingress gateway is in play. I know that I have an ingress gateway, but that it's not configured at all. So it's not listening or it doesn't have a listener set up. It's not pointed at a downstream service or an upstream service rather. So I'm going to configure those first. And in order to configure the ingress gateway, I need to set a service default. So service defaults are how we tell Consul what type of service they're interacting with. Typically, it's either TCP or HTTP. In this case, it's going to be HTTP, and we're doing that because we want to have that layer 7 visibility into the application. We want to be able to control traffic splitting, change the pathway that this application runs on. So we're going to set a service default value, and then we're also going to configure our ingress gateway for the first time. So I'm grabbing the code from another screen. I haven't left you all, don't worry. There's my first configuration entry. You can see it's a name, front end, kind, service defaults, and protocol, HTTP. Likewise, we'll come in here and we'll set up our actual ingress gateway. I think I need to make a change to this. Pretty sure that this is not HCS IDW in here. I think it's just ingress gateway. We're going to hope for it to be that at least. And we're going to keep listening on port 8080 with its own protocol of HTTP pointed at the front end service. I have this host tag here because we can actually control the way that it resolves. And if I don't have this host tag here, it will never actually return because it'll be expecting me to have an address that exactly matches the service. So this way I can just connect to the ingress gateway and it'll send me down. So those are set up. Things are looking good in this regard. So we will go ahead and apply this change. We can see I've got some changes in place. Master wants to push an update in, or it's seeing some changes. So what we'll do is we'll do a git add main.tf. We'll grab my little templated set of information there, and we'll do initial GW config. So that's push. We're going to very quickly get back into Terraform because this will happen. So we're planning out. Let's see if we have a break. We see it trying to run. We know it's going to add these configurations in place. It's given us kind of our plan view. And what it's doing now is it's asking us to confirm. And this gives us a nice little break for protecting ourselves from bad things happening. So I can confirm and apply. So what I'm going to do is Peter said to do it. Blame him. See, we have that git commit message here. Our apply finished, nothing broke. So Peter, your choice was correct this time. We'll go ahead and grab our ingress gateway's address. So I'll do a git service. Here's our ingress gateway. And it's on port 8080. So now if I come in, now I'm going to spoiler alert this a little bit. It's going to fail. So I will go to this address. You guessed that because I have a default deny in place, communication's not allowed, you are correct. So we need to add an intention to allow this communication. This to me is like one of the great examples of where the Git integration shines. Do you want somebody to be kind of on the fly, able to pop into the interface and just add another intention? Probably not. You want to have some level of governance around that, some level of control to make sure that the person's actually allowed to say front end can talk to the API, because what if front end is a malicious service? What if that is a service that you didn't want to be able to talk outside of a specific scope? This is a way of kind of protecting yourself from that. So default denies are a good thing. So what we're going to do is we're going to come in, we're going to add a Terraform resource for the intention. I'm going to change this one a little bit because this is not for. And so we're going to go IGW allow. This is just a friendly name in Terraform, just the resource name. It can be whatever you want it to be. Here we're going to go ingress gateway. To front end. Let's double check that language real quick just to make sure that I am not wrong. Yep, so it is called ingress gateway. That's what we want it to be. And if I go in and look at the intentions, I create an intention, we can see it in the list also as ingress gateway. So we are good on that. I'm gonna switch back in. Things look good. If somebody sees a mistake, please yell at me. Otherwise, I am going to go for it. Adding IGW intention. And very quickly get back into Terraform because it's fun to watch it run. See it running the planning stage. Doing a refresh, it's determined it's going to go ahead and add that intention. We're going to confirm it and apply. Peter still said it's okay. Confirmed, it's running now. And it has finished. And now if we switch back into console, we can see that that change has been put right there. Now, I want to call out, like, I'm committing directly into master. That's not always the greatest approach. Usually you would want, like, to have some PR process in there. Like, there's ways to do Git that is a little bit more safer than what I'm doing here. It's a demo, but know that, like, the process of, like, merging PRs is very much something we think about when we talk about the interaction model of Terraform Cloud. So consider that when you're thinking about how this GitOps style approach applies to you and how you would manage this in intentions. The intentions and configuration items for that matter. So that's done now. We've got communication in. It may take a few moments for this to come back up. No, I was completely wrong. It did not take a few moments. It was instant. So we're still not able to communicate on the back end. We can close this other one now. We're done with it. So this is running, but we don't have communication down to our API tier or our database tier at this point. So let's go ahead and fix that. So again, we'll come back in here. We'll grab this little block of code and use that as kind of our template. We'll do front end API allow. Front end API allow. We'll do the same thing for, oops, one doesn't help anybody. API DB allow. We'll update this to API, we'll update this to DB. Great. We have all of that set up now. It's fantastic. We subscribe to intentions RS. We're getting crazy now. Now what we'll do is we'll come into this view, and instead of sitting in Terraform Cloud and watching it, actually we have to go into Terraform Cloud because I have to approve the run. So it's adding those additional resources in. Confirm apply. Confirmed. What we'll do is we'll hang out here and we'll watch the console UI for a moment. And in just a few seconds, there it goes. Front end is in and the database is in. If we click back into our app, we can see everything's connected successfully. So now what if we want to change our application? What if we want to go ahead and switch this to a version 2 of the actual application? let's go ahead and show how we can do that. We do that via the layer 7 traffic policy. Remember earlier when I said we set these as HTTP services for a reason? This is that reason. We're going to flip these. Because we're using HTTP services, we can do layer 7 traffic management against this. We can interact with it based on the type of actual HTTP request that's in play. So in this case, we're going to go in and we're going to set up a traffic splitter that's going to say, I see you have 2 versions of front end. I want to send a percentage of traffic to either one of those. And what we're going to do is typically we would do this gradually. We would do like 10% of traffic to the new service, 20%, and ramp it up. We're going to do just a full cutover for simplicity because I've shown you guys so much so far. But it should illustrate pretty cleanly how you can move applications between environments. So let's pop back in here. We'll go this. Start editing again. Let me grab some sample code off to the side. Now, we do have a front-end service to V2, and let's just confirm that for everybody. If I go into my services list, we can see front-end V2 here. So we need to, similar to before, we need to set up our service default for that as well. So I've set up this front-end V2 service default. We're then going to grab a configuration entry for a splitter service. Oops. Copy and paste is hard. There we go. Front-end splitter is in play, service splitter, and we're controlling the flow of this traffic between those 2 services. If we were going to do 90/10, we're just going to cut the whole thing over to the new version. Actually, well, it's a little bit different. We're going to go 100/0, so we're going to keep it as is, but just apply the config, and then we'll make a secondary change where we update it to be the other service. To change that commit name, but here we are now, living our best life. We're running. We're removing the existing config and updating it. Yep. Just making sure everything looks good. Update it in place. Sounds good. Sounds good. Oh, actually, maybe it does not. No, it's good. Okay. That's going to run now. It's going to add that new service attention. It might error. There's a little race condition that sometimes happens. There we go. Did not error. So life is good. Things get really interesting here because we can come into our front-end service. We can come into routing, and we can see how this is split out inside the UI. I would stay tuned in this space. Little hint of the future. Stay tuned in this space after HashiCorp. There'll be some really cool things in here. So set to 100/0, split between these services. If I go back up here to the Ingress Gateway, do a refresh, things are good. We need to add an intention. Just remember, that would have been a sad demo fail. We're going to add another intention to allow our Ingress Gateway to talk to front-end V2. We have this Ingress Gateway allow here. We'll come back up with another version of it. Throw a number 2 on there. Come down here to V2. Good. Good, looking good. There we go. There it is. Do a 0 there. 100 there. So we're sending all of it to the new service. That is running now. Service is connecting. All things are good. Go back into our runs view. We can see it planning out to run again. We will let it apply. Confirm and apply. Here goes that apply. One added, 4 changed, life is good, refresh, and we have dark mode. We have made every developer in the company happy. However, we are having some denies on communication because this front-end V2 service is not set up for intentions. Now, this brings up a very interesting conversation point around designs and practical use of HCS. In this case, I registered a new service that was front-end V2, which means that it becomes a whole new path for intentions to run. Another way to do this would have been to register that V2 application as the same service, but leverage either tags or instance metadata to control which version is being used. And we can create these traffic splitting policies based on that metadata as well. So it's another path to being able to control traffic splitting. It's something that's very important to us, is how we control the flow of traffic once you're inside of that mesh. It's arguably one of the strongest capabilities that you get once you're in mesh, is the ability to life cycle applications from a network perspective. We have things like Kubernetes and Nomad that handle the running state of an application really well. We have Terraform that handles the infrastructure behind it. Vault handles the secrets management and the life cycle of a secret, but Consul allows us to manage that network connectivity life cycle of the way the services are connecting to each other. It's a very powerful thing. I have to use that phrase a lot today, so apologize. So we're looking good there. Our application's connecting. We're able to hit this back end. I'll go ahead and make 2 more changes to the code to kind of round out our demo. We're going to add the intentions for this to communicate fine. And then I'm also going to show how we can register external services with this environment as well. So back to the CLI we go. Editing main.tf again. This time we will just copy 2 of these because we need to make 2 intention changes anyways. We'll go V2 allow. Go front end V2 to API. Actually, we don't need the second one. That was a miscalculation on my part. Want to show you one more thing. We also have the ability to register external services against Consul. So if you wanted to be able to use that Consul dynamic registration, like all we've talked about so far is really focused on service mesh. But if you're in the service discovery world and you wanted to be able to map an external system that can't run a Consul agent, we can do that via Terraform as well by registering an external service. So I can go in and I can grab this configuration. There we go. It's on my other screen. One second, I'm just grabbing it off here. Quick edit. There we go. It's incoming. What we have now are 2 resources here. One is a Consul node, and then ultimately a service that rides on top of that node, set as an external service. Got a couple of intention changes in here, as well as registering a new service with Consul. This actually is a Postgres database, a managed Postgres database living inside of Azure. We can use a terminating gateway to work on that. If you want to see that, make sure you turn into HashiCorp, because I'm going to do that as part of interacting with another Terraform Cloud session. Intentions and external service. So that is complete now. So we will switch back into the UI and double check how things are looking. Go back into Terraform Cloud. Needs confirmation. That external service might fail. I think I had a typo in there that I'm thinking of right now. No fails. Life's good. See that external service registered here? Registered via Terraform. If we go into it, we can see that backend service. This actually does map to a Postgres database. So within Consul now, if I query postgres.service.consul, I will return this address. And if I do a dig against it and I look at the extension data, I'll also get the port name or the port number. So that's part of the power of service discovery within Consul. It's not all service mesh, right? We can also use this dynamic ability to register and resolve services as a way to make the way we scale applications and scale platforms much quicker. If we go back in here, we should see life getting close to being good now. Surprised it hasn't come back yet. Still working on it. Just taking a few. All of our configs are good here, so it's just waiting for it to finish the full switch over. Looking good. All right. That about covers the demo. We've been through configuring end-to-end Terraform Cloud to manage aspects of HCS. I'm going to hand this back over to Peter to take us home.
Absolutely. Thanks, Cody. That was great. So you're probably saying like, hey, this is awesome. How do I get started? So fortunately, it's pretty easy to do. In order to get started with HCS, you just go to the Azure portal. So we can also go to HashiCorp.com/HCS if you're looking for more information. Just want to give everybody a breakdown of like the different tiers that Cody had mentioned. So we do offer a development SKU. This is the pricing for that. It's all community supported. The idea is that this is something that if you just wanted to kick the tires on it, just get rolling, you'd be able to do that. Production, we do offer production on demand. So if you want to get started with like a smaller deployment, but maybe not ready for a full like annual commitment, then you could definitely do that. We offer uptime SLAs on that as well as bronze support. And then if you're looking for a larger deployment, just make sure you contact us. It does also include some features that are more in our enterprise. So the namespaces that Cody mentioned, as well as things like audit logging or SQL sign-on are available primarily through the annual. One note on the production SKU, I'll just say, that does cover you up to 10 nodes. Once you pass 10 nodes, there is a different pricing breakdown. For more information on that, go to our website where we do have that pricing listed out. And with that, we're going to open it up for questions. So we do have a couple already that came in. One thing that I'll just cover real quick, remind everyone this session has been recorded. We will be sharing out that recording. I'll also make sure, let's see if I can add the slides onto there as well, so you'll be able to use those. But to get started, Cody, one of the questions that came in is, does the external endpoint work with private link?
I don't believe that the external endpoint would. We think about this because the external endpoint is going to generate an external IP address. It's going to generate, it's going to throw basically like a load balancer in front of it. So I'm going to say that I don't think that that is private link. You could probably peer up the internal only one. So like obviously we expose it at the internal address. You could probably peer up that VNet into a private link and access it over private link. I'd have to confirm. I think that would probably work. Yeah, I'd have to double check on that. I think you would be able to peer a private link into the VNet for a non-exposed endpoint. But there's other ways to work around that too. Like you could expose the API via like an Nginx and then handle it via routing. That's another way to handle that. That would for sure work. So yeah, one quick thing, just because I feel obligated to finish a demo completely. That service did come back up, so we are connected. It just took a few moments for it to finish the intention stuff. So the demo was successful.
No smoke and mirrors. We're making sure that we finish it out.
Good magician always shows the end.
Yeah, absolutely. So we had another question come in about intentions, which I thought was good. It was asking if it's creating the Kubernetes network policies behind the scenes.
No, not in this case. You could still use Kubernetes network policies if you wanted to, as a separate construct. But in the case of like Consul, it's actually intentions are their own thing.
Awesome, thanks, Cody. We had a couple of people ask if you'd be able to post your demo code to be able to try it out for themselves.
Yeah. I don't see why not. That should be totally doable. I will, if you follow me on Twitter, I'm at Cody D. Arkland. I'll post the code. It's a pretty simple Terraform manifest, and then just my general demo app that I talk about all the time. So.
All right. Okay, so we're open for questions. Anything else coming in here? Let's take a look. One of the questions that did come in, someone asked about just like where HCS is available. We mentioned there is a direct portal access. So if you are going to the Azure Marketplace, you can log into your Azure account and get started right away. That's one of the benefits of HCS. We wanted to build it in natively, so you're not running in and trying to do like a third-party kind of workaround to get it all working together. This is like for users who are definitely heavy Azure users, like just go ahead and get started, spin up a development or a production cluster on demand, or talk to us and we'll see if we can do a different deployment. One of the things I'll also mention while we're waiting to see if there's any questions coming in, as Cody mentioned, we are doing some HCS, some HCP, and some console goodness at HashiCorp next week. If you have not already done so, I highly recommend registering for the event. It's going to be a lot of fun. Unfortunately, the workshops are unavailable at this point. We are at the end of, we are overbooked on that, but we are offering a lot of really cool demos and information. And as Cody kind of hinted at, we have a couple of really cool announcements that we will touch on the console front as well. All right. Well, it doesn't look like we have any questions, Cody. I think we nailed it all.
Awesome.
So with that, I think we can go ahead and give some folks some time back in their day. Once again, we did record the session. We'll make sure to get it published to our website. You'll probably get a follow-up email from us as well with a link when that's available. If you have any questions, feel free to reach out to us. And yeah, thank you all for joining today and have a great day.